Good morning everyone. This is Dr. Mamta from Government College Faridabad. Today we are just going to learn about metric space. So first of all, what is the metric space? That's meaning introduction. Then we will go to the definition and then we will go to the examples. Okay, so this is our criteria ki first of all introduction, then definition, then we will go via examples. Okay, so introduction, in introduction we just have to be check it out the definition of the absolute value function on R. What is this? So let function f such that R to R be a function defined by fx is equals to mod of x. This is called the absolute value of function. ठीक है, तो function is mod of x is equals to x whenever x is greater than 0 and this is equals minus x whenever x is less than 0 and this is equals to 0 whenever x is equals to 0. So mod x is defined like this. Okay, now we have to be talk about the properties of absolute value function. What is the properties? First property, mod of 0 is equals to 0. Second property, mod of a is greater than 0 if a is not equals 0. Okay, third property, mod of a is equals to mod of minus a. That's meaning कि it doesn't be interchange the value mod of a is equals to mod of minus a always. And fourth is mod of a plus b is less than equals mod of a plus mod of b. By a triangle we can also see that कि if we are getting out the sum of a plus b, this is greater than or equals c. Okay, so this is called the properties of absolute value function. Now we have to be take it out to x and y real numbers. The geometric interpretation of x mod of x minus y is said to be the distance function x to y. Okay, so from x to y we have to be check it out the distance, then we have to be check it out the mod of x minus y. Okay, so if we define the distance function by rho, the rho of xy is equals to mod of x minus y. Okay, then the properties first to fourth have the following consequence for any points x, y and z real numbers. Okay, now fifth property, rho of x to x. Okay, that's meaning the distance between x to x is equals to mod of x minus x. This is equals to 0. That is the distance between a point to itself. That would be equals 0. Next property is rho of x minus xy is greater than 0. That's meaning whenever x is not equals to y. So distance between x and y is positive whenever x is not equals to y. And the distance between two distinct function is strictly positively. Now we have to be check it out the another property, that is the rho of xy. It would be equals to rho of yx. That is the distance from x to y is equals to the distance from y to x. Okay, so this is called the symmetricity. Okay, next is rho of xy is less than equals rho of xz plus rho of zy. This is called the triangular inequality. Okay, the distance function satisfied if following the properties which are fifth to 8th, then we can say this is called a distance function. A distance function is usually called a metric function. Okay, then the definition. What is the definition? Let M be any set and a metric for capital M is a function rho with a domain M cross M and range is contained in semi-closed interval, that is 0 to infinite, such that for any element x, y, z of set M, then rho of x to x is equals to 0. Second, rho of means distance of x and y is greater than 0 whenever x is not equals to y. Rho of xy, that's meaning distance of xy is equals to distance between y to x, that is the symmetricity. And next, the distance between x and y is less than equals distance between x to z plus distance between z to y. Though then we can say कि rho is a metric for M, then the order pair M of rho is called a metric space whenever it follow the last properties. Okay, a metric for M thus has all the properties of the distance function mod of x minus y for R. Examples we can check it out over here. A function f such that r square to r be a function which is defined by f of xy is equals to mod of x minus y. Okay, then f is metric for R, then this metric is known as absolute value matrix. Okay, now another example, the discrete metric is defined by the formula distance between x and y is equals to 1 if x is not equals to y, and this is equals to 0 whenever x is equals to y. By the definition we knew it, the distance function d of xx is equals to 0. Number second, if x is not equals to y, then distance between x to y is equals to 1 definitely, which is positive. Clearly distance between x and y is equals to distance between y to x, and the triangular inequality distance between x and y is less than equals distance between x to z plus distance between z to y. Okay, if x is equals to y, then the left hand side is 0 and the inequality contains whole. If x is not equals to y, then the left hand side is equals to 1. Since x is not equals to y, we must have either x is not equals to y or else x is not equals to y. Okay, so thus the right hand side is at least 1 and the triangular inequality holds in any cases. Okay, now examples, some more examples. The plane r square with the usual metric space which is measures using the Pythagoras theorem. That's meaning the distance between x1 and y1 to x2 to y2 is equals to the square root of x1 minus x2 whole square plus y1 minus y2 whole square. This is sometimes called the 2 metric D2. Okay, this is also metric space for r square. That's meaning z is equals to x1 y1 and w is equals to x2 y2. Then we have to be check it out the distance between two points. Okay, some pictures will give in metric on the complex number c interpreted as the Argand diagram. In this case, the formula for the metric is now the distance between z to w is equals to mod of z minus w, where the mod in the formula present the modulus of the complex number rather than the absolute value of a real number. Okay, other example, the plane with the taxicab metric. What is that? The distance between x1 y1 to x2 y2, it would be equals to mod of x1 minus x2 plus mod of y1 minus y2. This is often called the one metric D1. Okay, the diagram is enclosed over there. Okay, now another example, the plane with the supremum or maximum metric. That's meaning the distance between x1 y1 to x2 y2, it would be equals to maximum value of x1 minus x2 mod and y1 minus y2 mod. This is often called the infinity metric space. The diagram is enclosed with it. Okay, other example we are just taking out here. To understand them, it has to look at the unit circles in each metric space. Okay, so this is the set x which is belongs to the r square, and distance between 0 to x is equals to 1. We get the following figure by this. Okay, another example, if rho is a metric on M, then 7 rho is also called the metric on M. Next, if rho and f are the metric on the M, then p plus rho plus f is also called the metric on M. Okay, but minus 7 rho is not a metric on M, since second property of the non-negativity shouldn't be satisfied by the rho. Okay, then the question, this is the time to do the question. Question is for you. This is the set of the all metric on set M is group. Okay, now we have to be talk about the some example which are not metric. Okay, so rho, whenever such that like this r square to r with a function defined by rho of xy is equals to 0. Okay, then rho is not metric. Since 1 is not equals to 2, but rho of 1 2 is equals to 0 by the definition of rho, the other properties are satisfied, but the distance between them is equals to 0. Okay, now we have to be take it out. The plane with the minimum function distance between x1 y1 to x2 y2, it would be equals to minimum value we have to be take it out between mod of x1 minus x2 and mod of y1 minus y2. Then the distance function is not a metric. Why? Since distance between 1 2 and 1 5 is equals to minimum value we have to be take it out. That's meaning mod of 1 minus 1 and mod of 2 minus 5. Then it would be minimum value of 0 3 and it would be equals to 0. Then second property is not satisfied. That's meaning we can say it would not a metric. Okay, now this is called the metrics examples, and we are just talked about the definition and something. Thank you so much for watching.